Imagine waking up one morning to find that an entire valley, a vast stretch of land, once brimming with rivers, forests, and villages, had simply vanished overnight. No earthquakes, no floods, no warning, just gone. This isn't the plot of a science fiction novel. It's a real phenomenon that has puzzled scientists, historians, and storytellers for centuries. Earth's lost valleys, these mysterious lowlands that disappeared without a trace, are more than just geological oddities. They're silent witnesses to the planet's restless, ever-changing nature, and their disappearances challenge everything we think we know about the ground beneath our feet. Picture a valley you've seen or hiked through, lush, alive, cradled between mountains. Now imagine it erased from the map, as if it never existed. Some of these vanished valleys were home to thriving ecosystems, ancient civilizations, even entire cultures. Their absence leaves behind fragments, a faded journal entry from a bewildered explorer, a half-remembered legend passed down through generations, or a sudden gap in the landscape where a river once flowed. How does something so vast, so solid, just disappear? And what clues are hidden in the earth, waiting to tell us their secrets? That's the mystery we're unraveling today. From the Himalayas to the Andes, valleys have vanished in the blink of geological time, some swallowed by sinkholes, others obliterated by catastrophic landslides, and a few with no explanation at all. We'll dive into the science behind these eerie disappearances, sift through historical accounts that sound more like myths, and explore how modern technology is finally shedding light on these ghostly landscapes. Along the way, you'll hear from geologists piecing together the puzzle, indigenous communities whose stories hold hidden truths, and even the occasional adventurer stumbling upon a valley no one knew was missing. This isn't just about rocks and maps, it's about understanding our planet's hidden stories and what they mean for the future of the places we call home. So let's begin the search for Earth's lost valleys and uncover the secrets they left behind. A vanishing valley isn't just a landscape slowly worn down by wind or water over millennia. It's something far more unsettling, a place that existed one day and was simply gone the next, as if the Earth itself had opened up and reclaimed it. These aren't the predictable changes we associate with erosion or even natural disasters like earthquakes. They're sudden, jarring events that leave behind gaping absences where valleys once thrived. Imagine a farmer tending his fields at dusk, only to wake at dawn and find the entire valley floor collapsed into a yawning void. Or a traveler returning to a familiar pass, now blocked by a mountain of rubble where a lush lowland had been. These aren't scenes from folklore, they're real occurrences etched into historical records and the collective memory of communities who witnessed them. Take the Himalayas, where entire valleys have vanished from maps without explanation. In the remote Zanskar region, elders speak of a valley called Kyunglung, once home to ancient temples and fertile lands, now reduced to a scattering of ruins perched on cliffs. Locals insist it didn't erode, it fell. Similarly, in the Andes, Spanish colonial accounts describe lowlands that disappeared overnight during heavy rains, leaving behind mud-choked basins where villages once stood. These stories were long dismissed as exaggerations until modern geologists began uncovering the truth. Skepticism once dominated the scientific community. How could something as vast as a valley vanish without a trace? But technology has rewritten the narrative. Satellite imagery and LiDAR scans now reveal the scars of these catastrophic events: hidden sinkholes, landslide debris, and even entire valleys buried under centuries of sediment. What was once myth is now measurable. The Atabad landslide in Pakistan, for example, swallowed villages and rerouted rivers in minutes, offering a stark modern parallel to these historical mysteries. What sets these vanishings apart is their speed. A typical landslide might take hours or days, but some valleys seem to have disappeared almost instantaneously. Indigenous stories often describe the ground breathing or swallowing the land, hinting at phenomena like subterranean cavern collapses or liquefaction, where waterlogged soil turns to fluid under pressure. These aren't gradual processes, they're geological snapshots of a planet in constant, unpredictable flux. And as we piece together these puzzles, one question looms: what forces could reshape the Earth so violently, so fast? The answers lie in the restless mechanics of the planet itself, shifting tectonic plates, hidden waterways, and the delicate balance of materials beneath our feet. But that's a story for the next chapter. Beneath the serene surface of valleys lies a hidden world of immense power forces capable of reshaping the land in an instant. Think of the Earth not as solid and unchanging, but as a dynamic, restless system where water, rock, and pressure conspire to create sudden, dramatic transformations. One of the most startling examples of this is the Atabad landslide in Pakistan, which unfolded in 2010. Without warning, an entire mountainside gave way, burying villages, blocking the Hunza River, and creating a massive lake where fertile farmland once stood. In just minutes, the landscape was rewritten. But what triggers such catastrophic events? Often, it's the silent work of underground water. When rainwater or melting snow seeps into the ground, it can saturate loose soil or weak rock layers, turning them into a slippery, unstable slurry. Add gravity to the equation, and entire slopes can liquefy and slide. In valleys built on shale or clay, softer rocks that absorb water like a sponge, the risk is even higher. These materials weaken over time until one day the pressure becomes too much and the land simply lets go. Then there are sinkholes, nature's sudden vanishing acts. In places like Florida or Central Asia, limestone bedrock is riddled with hidden cavities carved by acidic groundwater over centuries. When the roof of one of these underground chambers collapses, it can swallow homes, roads, or even entire sections of a valley in seconds. In 2013, a sinkhole in Louisiana consumed a chunk of forest so large it was visible from space. A stark reminder of how fragile the ground beneath us can be. Volcanic activity adds another layer of danger. In regions like Iceland or the Pacific Northwest, underground magma chambers can heat groundwater, creating pockets of steam that build pressure until the land above explodes or collapses. Even long dormant volcanoes can leave behind unstable terrain. The tragic 2014 eruption of Mount Ontake in Japan showed how quickly volcanic slopes can fail, burying valleys in debris without warning. Tectonic shifts play their part too. In earthquake-prone zones like the Himalayas or California, a single tremor can destabilize entire valleys by fracturing rock or triggering landslides. The 2015 Nepal earthquake, for instance, sent avalanches of rock and ice crashing into valleys below, altering the landscape in ways that will take centuries to heal. Not all valleys are equally vulnerable. Those in wet, mountainous regions with loose soil or fractured rock are far more likely to vanish overnight. Climate plays a role too. Heavy rainfall or rapid snowmelt can push already unstable slopes past their breaking point. But there's another factor at work, one that's entirely human. Deforestation, mining, and reckless construction strip away the natural anchors that hold valleys together, speeding up processes that would normally take millennia. In Indonesia, entire valleys have sunk after excessive groundwater pumping left the land hollow and brittle. These geological forces remind us that the Earth is anything but static. Valleys don't just disappear by chance, they're the result of intricate, often invisible processes that scientists are only beginning to fully understand. And while nature has always reshaped the planet in sudden, violent ways, human actions are now tipping the scales, making these vanishings more frequent and more devastating. The story of Earth's lost valleys isn't just about the past, it's a warning about the future. For centuries, humans have reshaped valleys to suit their needs, carving roads through mountains, diverting rivers, and flattening land for cities. But some of these changes come at a hidden cost, turning once stable landscapes into ticking time bombs. Take Indonesia's Java Island, where entire valleys have literally sunk into the ground. In places like Jakarta, relentless groundwater extraction for megacities has drained underground aquifers, causing the land above to collapse like a deflating balloon. Some areas sink by as much as 10 inches a year, swallowing homes and highways. It's a stark reminder that our thirst for progress can destabilize the very ground we build on. Deforestation plays a sinister role too. When trees are stripped from hillsides, their roots, nature's reinforcement bars, no longer hold the soil together. Heavy rains then wash away loose earth, triggering landslides that can erase valleys in moments. In the Philippines, rampant logging turned the once lush Ormoc Valley into a death trap. In 1991, after days of rain, a catastrophic mudslide buried entire villages, killing thousands. Survivors described the valley's collapse as a roaring wall of earth, moving faster than anyone could run. Mining operations dig even deeper into the planet's vulnerabilities. Open pit mines weaken bedrock, while tunnels hollow out subterranean support structures. In Germany's Harz Mountains, centuries of mining left the landscape so fragile that sudden sinkholes now appear without warning. One famously swallowed a highway overnight, leaving a crater 300 feet wide. Even abandoned mines pose risks. Their forgotten shafts can collapse decades later, taking valleys down with them. Urbanization adds another layer of pressure. Cities expand into floodplains and hillsides, adding weight to already unstable ground. When Mexico City paved over its ancient lakebed, the soft clay beneath compacted, causing parts of the metropolis to sink unevenly. Today, buildings tilt at eerie angles and underground pipes rupture as the earth shifts. These aren't just engineering challenges, they're warnings of how human ambition can outpace geological reality. Indigenous communities have often sounded the alarm first. The Quechua people of the Andes, for example, have long avoided building on certain slopes, citing ancestral knowledge of unstable ground. Similarly, native Hawaiian elders warned against disrupting the natural flow of water through valleys, noting how redirected streams could trigger erosion. Yet these voices are frequently sidelined in favor of short-term economic gains. The result: disasters like the 2014 Oso landslide in Washington, where ignored warnings about clear cutting led to a valley's catastrophic collapse, claiming 43 lives. The ethical dilemma is clear. How do we balance development with preservation? In Brazil's Serra do Mar region, a push for farmland and roads has destabilized mountainsides, causing landslides that erase entire valleys during rainy seasons. Yet the same land harbors endangered species and ancient forests found nowhere else. Similar conflicts rage in the Himalayas, where hydroelectric projects threaten fragile valleys sacred to local communities. But there's a shift happening. Scientists now partner with indigenous knowledge keepers, combining satellite data with oral histories to predict risks. In New Zealand, Maori elders work with geologists to monitor sacred valleys for signs of instability, blending tradition with technology. It's a model that acknowledges what we're only beginning to understand, that some landscapes aren't just resources to exploit, but but living systems that demand respect. So how do we detect these invisible tipping points before it's too late? The answer lies in cutting-edge tools that peer beneath the surface, revealing the hidden stresses that precede a valley's disappearance. From laser scans that map minute ground shifts to sensors that listen for the creaks of buckling rock, technology is finally giving us a fighting chance to predict the unpredictable. For generations, valleys that vanished were little more than whispers in old books or fragments of local legend until now. Today, cutting-edge technology is pulling these lost landscapes back into the light, peeling away layers of time with tools that would seem like magic to the explorers of the past. Take LiDAR, for example. This laser-based imaging system can see through dense jungle canopies, revealing the contours of the Earth hidden below. When researchers flew LiDAR over the Mosquitia rainforest in Honduras, they didn't just find traces of the fabled White City. They uncovered an entire network of valleys and settlements, lost for centuries under a green ocean of trees. The scans showed raised platforms, canals, and even roadways, painting a picture of a civilization that thrived before vanishing into the Earth's embrace. Satellite imaging has rewritten the map in places like the Sahara, where dried-up valleys now buried under sand are being rediscovered. By analyzing subtle differences in vegetation growth or soil moisture, scientists can spot the ghostly outlines of ancient riverbeds and lowlands that once pulsed with life. In 2018, a satellite survey revealed the remnants of a vast valley system in Libya, hidden beneath the dunes. These weren't just empty trenches, they held pottery shards and tools, silent proof of the people who lived there when the desert was still a lush paradise. Ground-penetrating radar takes the search even deeper, sending pulses of energy into the Earth to map what lies below. In Turkey's Cappadocia region, this technology exposed a sprawling underground valley, complete with homes and churches carved into the rock. The scans showed chambers and tunnels that had collapsed over time, solving the mystery of why early travelers described a valley that sank into itself. What's truly remarkable is how these tools don't just uncover the past, they help predict the future. By comparing modern scans with historical maps, geologists can track how valleys have shifted or sunk over decades, identifying areas at risk of sudden collapse. In the Swiss Alps, researchers use this data to monitor unstable slopes, giving communities early warnings before disaster strikes. It's a powerful fusion of old and new. Medieval monks' accounts of disappearing lands are now cross-referenced with real-time satellite data to piece together patterns we couldn't see before. The scientists behind these discoveries often describe moments of awe when the data clicks into place. One geologist working in the Andes recounted how LiDAR revealed a valley swallowed by a landslide centuries ago, a catastrophe described in Incan oral traditions but long dismissed as myth. The scans showed the exact path the landslide took, she said. It was like watching history play out in 3 dimensions. Yet for all their precision, these tools can't answer every question. Some vanished valleys leave no trace, their secrets locked away beneath layers of rock or water. Others tease researchers with partial clues, a strange depression in satellite images, an anomalous radar reading that hint at something larger lurking just out of reach. That's where the oldest records come in, the diaries of explorers, the sketches of early cartographers, and the oral histories of people who witnessed these landscapes before they were lost. These fragile, fading accounts often hold the key to understanding what the machines can't see, and sometimes they lead us straight to the next great discovery. Centuries before satellites or LiDAR, people witnessed valleys disappearing and struggled to make sense of these earth-shattering events. Their accounts scrawled in monastery ledgers, woven into oral traditions, or sketched on yellowed maps are time capsules of geological upheaval. Take the 12th century chronicles of English monk Gervase of Canterbury, who described a valley near Dunwich swallowed whole by the sea during a storm in 1181. Villagers reportedly heard a monstrous groaning from underground before the land gave way, leaving only cliffs where fertile fields once lay. Modern core samples confirm his account. The coastline there collapsed catastrophically due to unstable chalk beds undercut by waves. What medieval scribes called God's wrath, we now recognize as coastal erosion on a devastating scale. Half a world away, the Tohono O'odham people of Arizona tell of SI adjective at LHI adjective IGA breathe, the valley that breathed. Their ancestors spoke of a lowland near the Gila River that would rise and fall with the seasons until one summer, after heavy rains, it inhaled and never exhaled again. Geologists recently identified the site as a massive sinkhole now filled with sediment likely triggered when underground limestone caves, weakened by centuries of water flow, finally collapsed. The precision of these oral histories is staggering. Elders describe the exact sound of rock grinding against rock moments before the disappearance, matching modern recordings of sinkhole formation. Not all accounts are so easily verified. The infamous Vanishing Valley of the Carpathians appears in 15 Hungarian border records as a strategic pass that disappeared overnight in 1526, forcing armies to reroute. Some scholars dismiss it as wartime propaganda, but soil studies reveal a landslide-prone zone along the described route. Similarly, Arab merchant logs from the 13th century mention a salt valley near the Dead Sea that dissolved like sugar in water during an earthquake. Contemporary researchers found evidence of a brine-saturated depression that may have liquefied during seismic activity, a rare phenomenon called a saline collapse. These records do more than fascinate, they reveal patterns. When comparing indigenous Alaskan stories of singing glaciers that preceded valley collapses with Swiss farmers' diaries noting strange underground noises before landslides, scientists identified infrasound as an early warning sign. The Yupik tale of a valley near Nunapitchuk that sank into its own shadow during a full moon seemed poetic until researchers correlated it with lunar tide-induced groundwater shifts that destabilize permafrost. Even the timing of disasters repeats. Medieval French texts describe multiple valleys vanishing during spring, thaws precisely when modern geologists note heightened landslide risks from saturated soils. Separating fact from folklore requires detective work. The Welsh legend of Cantre Gwaelod, a fertile kingdom drowned when a priestess neglected a magical well, was long considered pure myth until sonar revealed orderly stone walls beneath Cardigan Bay, suggesting a real Bronze Age settlement lost to rising seas. Conversely, some vanished valleys in Renaissance maps were simply cartographic errors. Early mapmakers sometimes drew speculative landscapes to fill blank spaces, creating phantom geographies that puzzled later explorers. What emerges from these fragments is a startling consistency. Whether recorded by Viking skalds or Qing dynasty officials, descriptions of sudden valley disappearances share uncanny details. The scent of sulfur before volcanic collapses, the way birds fall silent before landslides, the hour of day often pre-dawn when groundwater pressure peaks. These aren't coincidences, they're human observations of geological processes we're only now learning to measure. When a 17th century Japanese poet wrote of a mountain valley near Fuji vanishing like a dream upon waking, his account seemed fanciful until core samples showed the entire area had sunk 11 feet during a quiet earthquake, a phenomenon undetectable without modern instruments. The true value of these historical whispers lies in their predictive power. By cross-referencing old flood records with LiDAR data, Dutch engineers recently identified 3 modern valleys at risk of catastrophic collapse areas where medieval dike failures had been dismissed as exaggerations. Meanwhile, in the Andes, Quechua stories about mountains, drinking valleys, helped pinpoint unstable zones where glacial meltwater is weakening bedrock today. These aren't just stories, they're early warning systems carved in time. And as we'll see next, they're also mirrors reflecting how cultures process the trauma of losing the very land beneath their feet. When a valley vanishes, it doesn't just leave a hole in the land, it leaves a void in the stories of the people who lived there. Across cultures, these lost landscapes become more than geological events. They morph into cautionary tales, divine punishments, or gateways to other worlds. In Celtic mythology, the Kingdom of Wise was said to be a lush valley protected by a great dike until a vengeful storm swallowed it whole, a story likely rooted in real coastal collapses along Brittany's shores. The legend warns of arrogance, the Princess Dahat, who allegedly opened the floodgates in a moment of recklessness, mirrors humanity's tendency to underestimate nature's fury. Halfway across the globe, the Navajo speak of Dizil Naudilii, a valley that walked away after its people broke sacred ecological taboos. The details vary, but the message is universal. Disturb the balance and the land itself might vanish. These myths aren't just fanciful explanations for the unexplainable, they're encoded survival guides. The Maori story of T1 Tapu, the Valley of Whispers, describes how the earth groaned for days before collapsing, teaching listeners to heed subtle warnings. Modern geologists now recognize these groans as the sounds of shifting rock, something instruments can detect hours before a landslide. Similarly, Himalayan Sherpas avoid building in certain valleys they call sleeping dragons, where the ground is said to breathe during monsoons. Scientists later found these areas sit atop underground rivers that swell unpredictably, destabilizing the earth. What was once spiritual intuition is now verifiable science, proving that folklore often holds kernels of observable truth. A collaboration between researchers and storytellers is rewriting history. In Alaska, Yupik elders shared an ancestral tale of a valley near Nunivak Island that sank like a canoe during a lunar eclipse. By cross-referencing the story's timing with tidal records, oceanographers identified a massive permafrost thaw event around 1751 that left behind telltale scars visible in sonar scans. Meanwhile, in the Andes, Quechua weavers' tapestries depicting the day the mountain drank the valley led archaeologists to a sediment layer matching the description of a catastrophic mudflow triggered by glacial melt. These partnerships reveal a truth: indigenous narratives aren't just poetry, they're oral archives of geological events, preserved with astonishing accuracy across generations. Even the language of these stories carries clues. The Welsh phrase, Cantrefig Gwaelod, drowned lowlands, appears in medieval texts describing valleys lost to rising seas, a phenomenon now confirmed by studies of post-Ice Age sea levels. In Japan, the term Jugoku Michai, Hell's Throat, refers to valleys that collapse during earthquakes, often near volcanic vents. Linguists tracing these terms have uncovered forgotten disaster zones, like the singing valleys of the Caucasus, where local dialects describe the eerie hum of methane gas escaping from fissures before collapses. But not all vanished valleys are mourned. Some are celebrated as portals. In Siberia, the Evenki people tell of Udagan, a valley that disappeared into the underworld, becoming a sacred bridge between realms. Finnish folklore speaks of Altojan Ala, under the waves, valleys said to resurface briefly every century, offering glimpses of the past. These narratives transform loss into mystery, suggesting that what's gone isn't truly lost, just hidden, waiting to be rediscovered. Today, scientists are learning to listen differently. When hydrologists in Peru heard elders describe a vanished spring as the place where the earth coughed, they realized it matched accounts of a long-dried aquifer collapsing. In Norway, researchers used Sami Joik's traditional songs about the valley that turned to smoke to locate a landslide site obscured by centuries of moss growth. The line between myth and data is blurring, revealing a profound truth. Our ancestors were the first geologists observing, recording, and passing down lessons we're only now beginning to decipher. And as we'll see next, those lessons are guiding modern science toward startling new theories about why valleys vanish and where they might disappear next. The Earth doesn't give up its secrets easily, especially when entire valleys vanish without leaving behind a clear culprit. But scientists have pieced together a handful of compelling theories that explain how these geological disappearances could happen so suddenly. One of the most dramatic involves glacial outburst floods, where melting ice sheets unleash catastrophic torrents of water with enough force to scour valleys clean. In Iceland, researchers documented a valley near the Vatnajökull glacier that literally emptied overnight when an underground ice dam burst. The floodwater carved through bedrock like a knife, leaving behind a barren trench where a thriving ecosystem once stood. Similar events in the Himalayas, triggered by climate-driven glacial retreat, have rewritten landscapes in mere hours, proving that ice holds the power to erase as well as create. Then there's the hidden menace of subterranean voids, vast caverns carved by groundwater over millennia, lurking just beneath the surface. When the roof of one of these chambers collapses, it can take everything above it down into the abyss. In Florida's Sinkhole Alley, radar scans have revealed a honeycomb of limestone caves, some so unstable that a single heavy rain can trigger a collapse. But the scale becomes truly staggering in places like the Yucatan Peninsula, where ancient Mayan legends describe the underworld swallowing the land. Modern surveys confirm their fears. Entire networks of valleys there sit atop flooded cave systems, and when support pillars crumble, the ground above vanishes without warning. Not all theories point to natural forces. Some geologists argue that human-induced seismic activity, like fracking or reservoir-induced earthquakes, can destabilize valleys already on the brink. In 2018, a series of small quakes near a hydroelectric dam in Laos coincided with the sudden sinking of a nearby valley. Researchers found that water saturation from the reservoir had lubricated fault lines, causing the land to slump like a deflated soufflé. It's a chilling reminder that our interventions can tip delicate geological balances with irreversible consequences. Of course, not every explanation holds up to scrutiny. Folklore is full of vanishing valleys blamed on vengeful spirits or divine wrath, but science offers more grounded answers. Take the case of Bolivia's Val de los Animas, where locals long believed a vanished lake was punishment for a broken taboo. Satellite imagery later revealed the truth. A massive sediment plug had given way, draining the water underground in a matter of days. Similarly, myths about singing sands preceding collapses in the Sahara turned out to describe the eerie vibrations of shifting dunes, a real precursor to sinkhole formation, not supernatural intervention. The biggest challenge: proving these theories when the evidence itself has disappeared. It's like reconstructing a crime scene where the victim and the weapon are both gone, admits Dr. Elena Petrov, a geologist studying vanished valleys in the Caucasus. Her team relies on indirect clues: sediment layers in nearby lakes, tree rings showing sudden trauma, even the chemistry of stalactites in caves, to piece together timelines. Sometimes the most telling evidence comes from what's missing: gaps in pollen records or abrupt changes in fossil assemblages that hint at ecological catastrophe. New models are emerging too. some researchers propose that certain valleys aren't vanishing but transforming, their floors rising due to tectonic uplift or sediment infill, effectively erasing them from view. Others point to liquefaction zones, where waterlogged soils behave like quicks and during earthquakes, swallowing everything atop them. But perhaps the most provocative theory comes from teams studying permafrost thaw in Siberia, where valleys are collapsing not downward but inward as once frozen ground slumps into thermokarst depressions. It's not just about things disappearing, explains Petrov. It's about the land reconfiguring itself in ways we're only beginning to understand. What unites these theories is their focus on instability, the idea that valleys exist in a fragile equilibrium, vulnerable to sudden, cascading failures. Whether it's water undermining bedrock, ice retreating too fast, or humans altering underground pressures, the triggers vary, but the outcome is the same: a landscape erased in the blink of geological time. And as we'll see next, some of the most striking examples of these vanishings aren't hidden in remote wilderness, they're etched into the histories of populated regions, where entire communities witnessed the earth giving way beneath them. The Alps have stood as Europe's silent sentinels for millennia, their peaks etched with the scars of countless avalanches and landslides. But few events shook these mountains like the disappearance of the Valpolar Valley in July 1987. One moment, it was a postcard-perfect Italian alpine basin, dotted with wildflowers and crisscrossed by glacial streams. The next, it was gone, swallowed by what survivors described as a wave of stone. The disaster began with an eerie prelude. Days of unseasonal rain had saturated the slopes, and locals reported hearing strange creaks echoing from the mountainsides. Then, without warning, 260 million cubic yards of rock, enough to bury Manhattan under 10 feet of debris, sheared off Mount Zandila in a single, catastrophic slide. The force was so immense it triggered seismic shocks mistaken for an earthquake 50 miles away. Eyewitness accounts read like scenes from a disaster film. A shepherd named Luigi Riva watched in horror as the valley floor beneath his flock seemed to liquefy, rolling like dough before vanishing into a churning sea of boulders. The landslide dammed the Adda River, creating a makeshift lake that threatened to burst and flood downstream villages. Engineers worked frantically to dig drainage channels, but the landscape had been altered beyond recognition. The town of Sant'Antonio Morignon, once nestled in the valley's embrace, now stood perilously close to a sheer cliff edge, its cemetery torn in half by the collapse. Over 3,000 people were evacuated, some never returning to homes that no longer had a valley to call their own. Geologists later pieced together the chain reaction that doomed Valpolar. The slope's instability traced back to the last ice age, when retreating glaciers left behind fractured rock held together only by friction and hope. The 1987 rains acted like grease on a fault line, seeping into cracks and dissolving the last bonds holding the mountain together. What made this event unprecedented was its speed. Most landslides creep or tumble, but Valpolar's collapse moved at nearly 100 miles per hour, a velocity usually seen in volcanic pyroclastic flows. The debris traveled so far it buried parts of a valley 3 miles distant, proving that in geology, distance offers no guaranteed safety. The aftermath became a laboratory for disaster science. Researchers discovered that the landslide had actually exposed an ancient valley floor buried by a similar collapse centuries earlier, a chilling reminder that history repeats itself in the Alps. Modern monitoring systems now dot the region, using lasers to detect millimeter-scale shifts in unstable slopes. But Valpolar left lingering mysteries. Why did some sections of the mountain remain intact while others disintegrated? Why did the slide accelerate so violently? And most hauntingly, could the next collapse be predicted? Or would the mountains keep their secrets until it was too late? Perhaps the most profound lesson came from the survivors themselves. Elderly farmers who'd spent lifetimes in the valley spoke of subtle warnings they'd dismissed: springs that ran muddy weeks before the disaster, livestock that refused to graze near certain cliffs. Their observations mirrored indigenous knowledge from the Andes and Himalayas, proving that sometimes the oldest warnings are the most precise. Today, Valpolar's ghost lingers in altered river courses and displaced villages, a stark monument to nature's power to rewrite geography in an instant. And as we'll see next, this wasn't an isolated tragedy, just one dramatic chapter in a global story of vanishing landscapes. Central Asia holds some of the planet's most surreal disappearing acts, nowhere more shockingly than in Kazakhstan's Turgei Depression, where an entire valley literally dropped off the map. In 2019, a herder tending his flock near the village of Shalkar stumbled upon a site that seemed ripped from science fiction, a gaping crater over 300 feet deep, where just weeks before, gentle lowlands had stretched as far as the eye could see. The earth hadn't just collapsed, it had vanished, leaving behind a jagged maw exposing layers of sediment untouched by sunlight for millennia. But this wasn't just a geological oddity. As scientists rappelled into the abyss, they uncovered something far more extraordinary. The walls were studded with prehistoric fossils, mammoth tusks, ancient horse skeletons, even stone tools, all preserved in stunning detail. The valley hadn't just disappeared, it had become a time capsule, offering a glimpse into a world long lost. What caused such a dramatic collapse? The clues point to a perfect storm of human and environmental factors. For decades, Soviet-era irrigation projects had diverted rivers to feed cotton fields, draining underground aquifers that once stabilized the region's soft sedimentary rock. Then came climate change. Rising temperatures accelerated evaporation, while erratic rainfall patterns further stressed the already depleted water table. The land, essentially parched and hollowed out, finally gave way. Dr. Ayman Saparova, a geologist who studied the site, describes it as like removing the supporting beams from a mine shaft. The collapse was so sudden that satellite images captured before and after show the valley intact 1 month, gone the next. The race to document the crater's treasures before they're lost forever feels like something out of an adventure novel. Wind and rain erode the exposed walls daily, causing fossils to crumble before they can be catalogued. Local archaeologists work against the clock, braving unstable terrain to recover artifacts that rewrite the region's history. A Neolithic axe here, a Bronze Age pottery shard there. Even more haunting are the traces of ancient human activity, fire pits and animal bones suggesting this valley was a seasonal hunting ground for thousands of years before it became a ghostly pit. But the Turgei Depression isn't alone. Across Central Asia, similar sinkholes, some spanning entire football fields, have swallowed valleys in Mongolia's Gobi Desert and Uzbekistan's Amu Darya Basin. Each follows a chillingly familiar pattern. Decades of unsustainable water use weaken the land, then a trigger, a heavy rain, a minor earthquake pushes it past the breaking point. In Turkmenistan's Karakum Desert, the infamous Gates of Hell crater, a fiery sinkhole burning since 1971, shows how these collapses can become permanent scars on the landscape. What makes Central Asia's vanishing valleys especially alarming is their acceleration. Historical records show such events occurred naturally over centuries, but now they're happening within human lifetimes, a direct consequence of pushing fragile ecosystems beyond their limits. The same forces destabilizing Kazakhstan's lowlands are at work globally, from Florida's sinking suburbs to Indonesia's drowned rice fields. As temperatures rise and groundwater extraction intensifies, the question isn't whether more valleys will disappear, but where and what secrets they might take with them when they go. The planet is heating up at an alarming rate, and the Earth itself is responding in ways that rewrite landscapes overnight. Rising global temperatures aren't just melting glaciers or raising sea levels, they're fundamentally altering the stability of valleys worldwide, turning once solid ground into ticking time bombs. Take the Arctic, where permafrost that's remained frozen for thousands of years is now thawing at an unprecedented pace. In Siberia, entire sections of valleys are collapsing into thermokarst depressions as the icy glue holding the soil together melts away. These aren't gradual changes. In 2020, a valley near the Yonne River basin sank 30 feet in a single day, leaving behind a jagged scar visible from space. The cause: underground ice lenses. Layers of frozen water that once acted like scaffolding turned to liquid, causing the land above to pancake into the void. But it's not just the cold regions feeling the heat. Intensified rainfall, another hallmark of climate change, is saturating soils beyond their limits. In the Colombian Andes, a phenomenon called soil liquefaction is becoming alarmingly common. When weeks of heavy rain seep into loose volcanic sediments, the ground can transform into something resembling quicksand. Entire hillsides slide away in minutes, swallowing valleys whole. The town of Mocoa learned this devastating lesson in 2017 when a once stable valley gave way after 36 hours of non-stop rain, sending a wall of mud and debris crashing through neighborhoods, claiming over 300 lives. Survivors described the sound as thunder coming from underground, a visceral reminder that climate change doesn't just alter weather, it reshapes the very earth beneath our feet. Scientists now warn that certain regions are entering a danger zone unlike anything seen in recorded history. The Caucasus Mountains, where ancient glaciers are retreating at breakneck speed, are seeing entire valleys destabilized as meltwater infiltrates fractures in the bedrock. Satellite images show alarming bulges on mountainsides in Georgia's Svaneti region, signs that slopes once held firm by ice are now creeping toward collapse. Meanwhile, in the Himalayas, glacial lakes swollen by melting ice threaten to burst through natural dams, sending devastating floods downstream that can scour valleys down to bedrock in hours. The 2021 disaster in Chamoli, India, where a glacial outburst flood obliterated a hydropower plant and wiped out a valley's infrastructure, offers a grim preview of what's to come. Predicting which valleys might vanish next has become a grim science of its own. Researchers point to the Andes' hollow mountains, where centuries of mining have left networks of tunnels that, when combined with glacial melt, create perfect conditions for catastrophic subsidence. In Alaska's Brooks Range, radar scans reveal that 40% of surveyed valleys now sit atop thawing permafrost, with some areas sinking at rates of several inches per year. Even temperate regions aren't immune. Unusually intense rainfall in Germany's Ahr Valley triggered 2021 floods that stripped away entire hillsides, proving that no landscape is truly safe from climate-driven collapse. The urgency to adapt has never been greater. Traditional engineering solutions like retaining walls or drainage systems are proving woefully inadequate against these new climate-amplified threats. Some communities are taking radical steps. The Swiss village of Brienz, perched above an unstable valley, has installed a network of sirens that blast when movement sensors detect impending landslides, giving residents minutes to flee. In Nepal, engineers are experimenting with glacial acupuncture, using pipes to drain dangerous meltwater before it can accumulate, but these are stopgaps at best. The real challenge lies in rethinking how we inhabit vulnerable landscapes, balancing centuries-old settlements against the reality of a planet that's becoming geologically unpredictable. As valleys continue to vanish at an accelerating pace, they take with them more than just land. They erase ecosystems, histories, and the very contours that define regions. The ripple effects extend far beyond the immediate collapse, disrupting watersheds, altering microclimates, and forcing species into sudden, often disastrous migrations. And in this unraveling, we're reminded that the Earth's surface is not the immutable stage we once imagined, but a dynamic, fragile skin, one that's now responding violently to the pressures we've placed upon it. The next chapter in this story isn't just about why valleys disappear, but what their absence means for the intricate web of life they once supported. When a valley vanishes, it doesn't just take chunks of Earth with it, it unravels entire ecosystems, severing connections that took millennia to form. Picture a high-altitude Himalayan valley, home to snow leopards that prowl its ridges and rare blue poppies that bloom only in its microclimate. When such a place collapses into a landslide, the snow leopards lose critical hunting grounds, forced into conflict with humans as they roam farther for prey. The poppies, with roots adapted to that specific slope's soil and moisture, simply vanish, their genetic blueprint erased forever. These aren't hypotheticals. In Nepal's Mustang region, a valley's sudden collapse in 2019 wiped out one of the last habitats of the Himalayan quail, a bird already teetering on extinction. Its disappearance wasn't just a loss for ornithologists, it disrupted seed dispersal patterns, triggering a cascade that altered the valley's plant composition for years to come. Water systems suffer some of the most immediate shocks. Valleys often act as natural basins, channeling rivers and filtering groundwater through layers of sediment. When they collapse, the plumbing of the landscape gets ripped apart. In the Andes, the abrupt disappearance of a valley near Huaraz in 2017 diverted a glacial-fed river underground, leaving downstream farms parched and killing off a unique population of rainbow trout that had thrived in those cold, clear waters for centuries. Meanwhile, in Central Asia, sinkholes swallowing valleys have drained entire wetlands, dooming migratory birds like the Siberian crane that relied on these oases during their epic journeys. The ripple effects stretch across continents. Fewer cranes mean fewer seeds dispersed, which means fewer new trees in forests thousands of miles away. Some species cling to existence in the fragments left behind. In the Caucasus, a rare cave-dwelling beetle survived the collapse of its valley by retreating into deeper caverns, but with its primary food source fungus that grew only near the valley's entrance, now cut off by rubble, its population has plummeted. Conservationists face agonizing choices, attempt risky relocations or watch species blink out one by one. In New Zealand, biologists racing to save the orange-fronted parakeet from a collapsing valley airlifted eggs to captivity, only to discover the birds refused to breed without the specific acoustics of their lost home's limestone cliffs. Sometimes the bond between a species and its valley is too precise to replicate, yet there are glimmers of resilience. In California's Sierra Nevada, a landslide that erased a valley in the 1980s unexpectedly created new ponds in the rubble, attracting a population of yellow-legged frogs thought to be extinct. Similarly, the sudden exposure of ancient groundwater in a collapsed Kazakh valley has given rise to a bizarre new ecosystem where extremophile microbes thrive, offering scientists a glimpse into how life might adapt on other planets. These accidents of geology remind us that nature's responses are as unpredictable as its disruptions. Human efforts to mend these broken ecosystems range from the desperate to the ingenious. In Bhutan, engineers are building artificial cliffs to replace lost nesting sites for endangered vultures. In the Alps, helicopters drop soil mixed with native seeds onto landslide scars, hoping to kickstart regeneration. But the most promising work comes from those who have lived alongside these valleys longest. Quechua farmers in Peru, noticing that certain potatoes grew better in landslide debris, began deliberately cultivating these resilient strains in other at-risk valleys, creating food security buffers against future collapses. Their wisdom underscores a hard truth. Ecosystems can't always be restored, but they can sometimes be reinvented. The story of these vanishing valleys isn't just about geology or ecology. It's about the people whose lives are woven into these landscapes. When a valley disappears, it takes with it the stage for countless human stories. The shepherd's ancestral grazing routes, the forager's secret mushroom patches, the children's swimming holes where generations learned to swim. These losses are measured not just in species or square miles, but in the quiet unraveling of ways of life that depended on valleys that were never supposed to vanish. And as we'll see next, for those who call these unstable landscapes home, survival often means rewriting their relationship with the earth itself. The ground doesn't just vanish, it takes with it the stories of those who walked upon it. In the remote village of Hunza, nestled in Pakistan's Karakoram Mountains, the Atabod landslide didn't just block a river, it erased an entire way of life. Overnight, 20,000 people found themselves cut off from schools, hospitals, and ancestral farms as the rising waters swallowed the Karakoram highway, their lifeline to the outside world. For the Hussein family, who had farmed apricots in the valley for 7 generations, the disaster meant more than lost land. It was the unraveling of a lineage. Our trees were like family, recalls elder Bakhtiar Hussein, pointing to where his orchard now lies under 60 feet of water. You can rebuild a house, but how do you replant centuries? The emotional toll of these events lingers long after the landslides settle or the sinkholes stabilize. In Colombia's Salga region, where a sudden valley collapse in 2015 killed over 80 people, survivors describe a peculiar grief, not just for the lost, but for the landmarks that anchored their memories. The boulder where teens used to meet after school, the bend in the river where couples whispered promises, the shade tree that marked the village's founding spot, all gone, leaving survivors untethered from their own histories. Psychologists working in the area report higher rates of topographical grief, a form of mourning for lost landscapes that Western medicine barely recognizes. Economic devastation follows close behind. When Nepal's Sindhupalchok Valley vanished during the 2015 earthquake, it took with it not just homes but an entire cottage industry. The valley's red clay had produced pottery prized across the Himalayas, its unique mineral composition yielding ceramics that could withstand extreme temperatures. Today, the remaining potters work with inferior clay trucked in from distant regions, their wares no longer commanding premium prices. Our grandfather's craft died with that valley, says artisan Lakshmi Gyurung, kneading imported clay with hands still stained from her native soil. Yet amidst the loss, there are extraordinary tales of reinvention. In the Swiss Alps, where the Valpolar landslide displaced 3 villages in 1996, residents didn't just rebuild, they reimagined. Using insurance payouts and government grants, the community pooled resources to construct earthquake-resistant homes with shared geothermal heating, turning disaster into innovation. Their new church, built on stable bedrock, features a bell salvaged from the drowned valley below, a literal echo of the past ringing into the future. Similarly, in Indonesia's Sidoarjo region, where a mud volcano swallowed 13 villages in 2006, survivors transformed tragedy into tourism. They now guide visitors through the surreal landscape of half-submerged buildings, using the disaster to fund scholarships for displaced children. Perhaps the most profound resilience comes from those who blend ancient wisdom with modern science. In the Andes, Quechua communities facing recurring valley collapses have revived a pre-Incan practice called Aini, a reciprocal labor system where neighbors help each other rebuild. But they've adapted it for the 21st century, using GPS to map safe zones and blending traditional adobe with seismic-resistant rebar. "The earth moves, so must we," explains community leader Tomas Quisp, showing blueprints for homes with flexible bamboo frames that sway rather than collapse during tremors. These stories reveal a universal truth: when valleys vanish, they take more than dirt and rock. They take the stage upon which lives unfold, the backdrops to first kisses, harvest festivals, and childhood adventures. But they also reveal humanity's stubborn refusal to let geography dictate destiny. From Swiss engineers to Andean elders, people are rewriting the playbook on disaster recovery, proving that even when the ground disappears beneath our feet, we can still find footing in community, creativity, and the indomitable will to rebuild. And sometimes, as we'll see next, these tragic events expose treasures long hidden beneath the surface, artifacts and fossils that rewrite history, even as the present landscape collapses around them. Sometimes, when the earth swallows a valley whole, it gives something back in return, not just rubble, but revelations. These catastrophic collapses have a way of cracking open time capsules, exposing layers of history that would have otherwise remained buried. Take Chile's Atacama Desert, one of the driest places on Earth, where vanishing valleys have become accidental archaeological gold mines. When flash floods stripped away sediment in 2019, they revealed a trove of prehistoric tools: stone spear points, grinding stones, even fragments of woven baskets left behind by hunter-gatherers over 9,000 years ago. The artifacts were so perfectly preserved in the arid climate that researchers could still see fingerprints pressed into the clay of an ancient cooking pot. What was once a tragedy of erosion became a window into a world when humans first learned to thrive in this brutal landscape. But it's not just tools that emerge from the wreckage of vanished valleys. In the Caucasus Mountains, a landslide in 2017 exposed something far rarer: an entire Bronze Age settlement frozen in mid-collapse. The debris field held not just pottery and weapons, but the ghostly outlines of wooden homes crushed by the very same geological forces that preserved them. Archaeologists found dinner bowls still holding petrified grains, a child's leather shoe tucked under a collapsed wall, even the remains of a family huddled together, a haunting snapshot of a disaster millennia ago that mirrored modern tragedies. The valley's destruction had essentially created a prehistoric Pompeii, sealed under layers of protective mud until the land decided to give up its secrets. These discoveries come with thorny ethical dilemmas, though. When artifacts emerge in unstable terrain, every dig risks triggering another collapse. In Turkey's Cappadocia region, researchers working on a freshly exposed Roman-era valley face agonizing choices daily. "We're racing against the mountain itself," explains archaeologist Defne Kaya. "Do we painstakingly document each layer as it crumbles, or do we try to extract artifacts before they're lost forever?" Some argue for high-tech solutions, 3D scanning everything in situ, then letting the valley reclaim what remains. Others insist certain finds are too precious to leave to the elements. The debate grows even more heated when human remains are involved, pitting scientific curiosity against cultural respect and the safety of excavation teams. The legal battles can be just as treacherous as the shifting ground. In Peru, a valley collapse near Machu Picchu exposed a network of Inca-era tunnels in 2020, one only for disputes to erupt between the government, local indigenous groups, and international researchers over who had the right to study or rebury what was found. Similar conflicts simmer in Alaska, where thawing permafrost is exposing Yupik burial sites in collapsing valleys. These aren't just academic quarrels, they're clashes over who gets to tell the stories of the vanished and how. Yet for all the challenges, these accidental time machines are rewriting history books. A sinkhole in China's Guangxi region revealed a valley filled with fossils of giant pandas from 2 million years ago, proving the species once roamed much farther south. In Spain's Pyrenees, a slumped valley yielded Neanderthal teeth embedded in cave bare bones, gruesome evidence of interspecies competition. Each discovery peels back another layer of Earth's memory, offering clues about how humans and animals adapted or didn't to ancient climate shifts not so different from our own. What makes these sites uniquely poignant is their fleeting nature. The same forces that expose them inevitably destroy them, leaving scientists to document what they can before the evidence vanishes again. Italian geologist Marco Menischetti describes it as archaeology in reverse, watching as a valley slowly eats its own history. His team recently salvaged medieval coins from a collapsing alpine valley, only to return the next day and find the entire strata they'd been studying had slid into the river below. It's a reminder that these windows into the past are as temporary as the valleys that briefly held them. As we piece together these fragments, one unsettling truth emerges. Many of these ancient societies collapsed alongside their valleys, victims of the same geological instability we grapple with today. Their pottery shards and abandoned tools aren't just artifacts, they're warnings carved in clay and stone. And as we look toward the future of Earth's vulnerable landscapes, these messages from the past have never felt more urgent. The clock is ticking for some of Earth's most fragile valleys, and scientists are racing to predict which landscapes might vanish next before it's too late. In the Canadian Arctic, radar scans reveal the Peel River Valley is sitting on a time bomb of thawing permafrost, its slopes already sinking at a rate of several inches per year. Similar warnings echo from the Swiss Alps, where the Matter Valley shows unsettling cracks along its glacial moraine, signs that melting ice is loosening its grip on the bedrock below. But perhaps nowhere is the threat more immediate than in Indonesia's Salta Valley, where reckless groundwater extraction has turned the land into a brittle shell. Satellite images show vast sections of the valley floor sinking nearly a foot annually, with geologists warning it could collapse catastrophically during the next monsoon season. Stopping these disappearances requires more than just observation, it demands action. Early warning systems are becoming lifelines for at-risk communities. Japan's Shizuoka Prefecture, home to the unstable Omizaki Valley, now uses a network of underground sensors that detect microscopic shifts in rock layers, sending alerts to residents' phones hours before potential landslides. Meanwhile, in Norway's Romsdalen Valley, engineers are testing biocementation, a process where bacteria are injected into unstable slopes to secrete natural cement, strengthening the soil from within. These innovations aren't just high-tech, some borrow from ancient wisdom. Peruvian engineers, inspired by Inca terrace systems, are building stone-reinforced steps into crumbling Andean valleys to slow erosion, combining 21st-century materials with thousand-year-old designs. The fight to save these landscapes is forging unlikely alliances. The Transboundary Valley Initiative, a coalition of scientists from Kazakhstan, China, and Russia, shares real-time data on the vulnerable Ili River Valley, where competing water demands once fueled political tensions. Similarly, in the Himalayas, Buddhist monks work with NAS, a glaciologist, to monitor sacred valleys using both prayer flags and satellite telemetry, a spiritual and scientific early warning system. These collaborations prove that valleys don't recognize borders, and neither should the efforts to protect them. Yet technology alone won't solve the crisis. We need to rethink how we use the land. In California's Napa Valley, vineyards once notorious for soil depletion now pioneer regenerative agriculture, planting deep-rooted cover crops that anchor slopes against landslides. In Bhutan, entire villages have relocated from unstable valleys to sustainable, earthship communities built from recycled materials, proving development doesn't have to mean destruction. Even tourists are becoming allies. Norway's Geopark program trains visitors to photograph cracks in valley walls, crowdsourcing data that helps predict collapses. The challenge is staggering but not insurmountable. From the AI-powered landslide forecasts being tested in the Italian Dolomites to the Valley Guardians program empowering Kenyan farmers to replant erosion-fighting trees, solutions are as diverse as the threatened landscapes themselves. What unites them is urgency and the understanding that every valley saved is a victory against the silent crisis reshaping our planet. And for those who want to witness these disappearing wonders while they still exist, powerful tools now put the planet's most vulnerable landscapes at your fingertips. You don't need a time machine or an expedition budget to uncover Earth's vanished valleys, just an internet connection and a sense of curiosity. Start with Google Earth, a treasure trove of satellite imagery where disappearing landscapes leave behind subtle but telltale clues. Zoom into the Himalayas and toggle between historical and current views to spot valleys swallowed by landslides, their outlines still faintly visible like ghostly scars. Switch to 3D mode to tilt the terrain, revealing unnatural depressions or abrupt elevation changes that hint at catastrophic collapses. For a deeper dive, Google Earth's time-lapse feature lets you watch decades of change unfold in seconds, like the dramatic retreat of Alaska's Barry Glacier, which triggered an entire valley's collapse in 2015. But satellite images only tell part of the story. Geological survey websites like the US Geological Survey's Landslide Inventory or the British Geological Society's sinkhole maps overlay scientific data onto these visuals, pinpointing unstable zones with eerie precision. Many of these platforms offer raw LiDAR datasets, letting you strip away vegetation to see the bare earth beneath. It's how amateur sleuths recently identified a vanished valley in Scotland's Glencoe, hidden for centuries under dense forest until laser scans exposed its ancient riverbeds and landslide debris. For historical context, digital archives are gold mines. The David Rumsey Map Collection hosts centuries-old atlases where cartographers sketched valleys that no longer exist, like the Valles Penitentium in the Alps, erased by a rockslide in 1789. Compare these with modern topographic maps, and you'll spot discrepancies that reveal vanished landscapes. Meanwhile, university libraries often digitize explorers' journals. Stanford's collection includes 19th-century surveyors' sketches of California valleys later drowned by reservoirs, their original contours preserved in fragile ink. If you prefer guided exploration, documentaries like PBS's Vanished series or the BBC's Earth's Lost Worlds weave science and storytelling, reconstructing disappeared landscapes through CGI and expert interviews. For auditory learners, podcasts like the Atlas Obscura or Bedrock feature episodes on legendary sinkholes and ghost valleys, often interviewing geologists who have witnessed collapses firsthand. Bookworms should hunt down The Lost Valleys of the Andes by anthropologist Maria Reich, which blends archaeology with gripping accounts of indigenous communities adapting to shifting landscapes. The most thrilling option, join a citizen science project. Platforms like Zooniverse host initiatives where volunteers analyze satellite images to flag emerging sinkholes or unstable slopes. In 2022, a retired teacher in Oregon spotted a previously unnoticed depression in Mongolia's Go by Desert This Way, later confirmed as a collapsing valley linked to underground coal fires. Other projects like the Smithsonian's Global Volcanism Program train amateurs to monitor signs of valley instability near active volcanoes, contributing data that professionals use to predict disasters. Of course, with so much information at our fingertips, myths thrive alongside facts. Some claim vanished valleys are evidence of ancient advanced civilizations or extraterrestrial interference, while others insist they're divine punishment. But as we'll see next, the truth behind these disappearances is stranger and more fascinating than any fiction. When a valley vanishes without warning, it's human nature to grasp for explanations, especially ones that feel bigger, stranger, or more dramatic than the slow grind of geology. Over the centuries, these disappearances have been blamed on everything from angry gods to bored extraterrestrials. Take the infamous Devil's Sinkhole in Texas, where 19th century settlers swore the ground opened up because of a preacher's curse. Never mind that the limestone underneath had been dissolving for millennia, it made for a better story. Similarly, when a valley in Turkey's Cappadocia region collapsed overnight in the 1950s, rumors spread that ancient underground cities had awakened. Ignoring the far simpler truth, centuries of rainwater had finally weakened the soft volcanic rock beyond its breaking point. Some myths persist because they're entertaining. The idea that vanishing valleys are landing strips for UFOs gained traction in the 1970s after a tabloid published a doctored photo of a perfectly rectangular sinkhole in Nevada. Never mind that real sinkholes are never geometrically precise, the image went viral before viral was a thing. Even today, you'll find forums speculating about government energy experiments when a new collapse makes headlines. But the most stubborn myths are the oldest ones. In the Andes, Quechua legends speak of huacas, spirits that punish greed by swallowing valleys whole. While these stories carry cultural wisdom about respecting nature, modern seismology tells a different tale. The valleys vanished because tectonic pressures finally overcame friction, not because someone offended a mountain deity. Science dismantles these fantasies with cold, hard data. When a valley in China's Guangxi region disappeared in 2018, conspiracy theorists blamed underground nuclear tests until geologists pointed to the area's karst topography, where sinkholes are as natural as rain. Ground-penetrating radar showed no secret tunnels or alien artifacts, just water-weakened limestone doing what it's done for eons. Similarly, the Bermuda Triangle of the Alps myth, which claims a cluster of vanished valleys in Switzerland, is a portal to another dimension, falls apart when you examine the region's glacial history. Retreating ice left behind unstable moraines that were destined to collapse, no paranormal passport required. Then there are the downright bizarre theories. A 19th century German geologist once proposed that vanishing valleys were caused by cosmic gas pockets exploding like subterranean balloons. More recently, an internet meme insisted that goats' hooves generate harmonic vibrations capable of destabilizing entire landscapes, a claim debunked by physicists who calculated you'd need roughly 70 million goats stomping in unison to achieve such an effect. These ideas might sound laughable now, but they reveal something important: our tendency to romanticize the unknown, to prefer a thrilling lie over a mundane truth. What's fascinating is how these myths mirror the anxieties of their time. Medieval accounts blamed vanishing valleys on divine wrath during plagues. The industrial era spawned tales of mole people tunneling recklessly with steam machines. Today, our fears manifest as government cover-ups or rogue AI experiments. The real story is less cinematic but no less awe-inspiring. Earth's surface is a dynamic, ever-shifting system where water, rock, and gravity conspire in ways we're still learning to predict. Perhaps the most persistent myth of all is that these events are unnatural, that stable landscapes shouldn't vanish. But geology knows no should, it simply is. Valleys disappear because the planet is alive in the slowest, most inexorable sense, rearranging itself according to rules written long before humans walked its surface. And that realization leads to deeper questions about our place in this impermanent world, questions that have haunted philosophers and poets as much as scientists. If even mountains aren't permanent, what does that mean for the cities we build upon them, for the stories we tell about them? The answers might not lie in ancient curses or alien tech, but in something far more profound: the humility to accept that we live on a planet that never promised to stay still. There's something profoundly humbling about standing at the edge of a vanished valley, gazing into a gaping absence where life once thrived. These geological ghosts force us to confront an uncomfortable truth: the ground beneath our feet, the landscapes we etch into memory, the very stage upon which human history unfolds, is fleeting. Valleys that vanish overnight are more than just geological oddities. They're visceral reminders of our place in a timescale far grander than our own. The philosopher Alan Watts once wrote, "The only way to make sense out of change is to plunge into it, move with it, and join the dance." These lost lowlands are Earth's way of dancing, reshaping itself with a rhythm measured not in human lifespans, but in the slow, inexorable beat of plate tectonics and erosion. Consider the writings of John Muir, who wandered the Sierra Nevada's valleys in the 19th century, marveling at their eternal solidity. Yet today, some of those same valleys are buckling under the weight of climate change, their glaciers retreating, their slopes destabilizing. Muir's eternity lasted barely a century in geological terms. This dissonance between human perception and planetary reality echoes in the works of Japanese poet Basho, who scribbled haiku about mountains crumbling like sandcastles during his travels. His words, penned in the 1600s, feel eerily prescient now, as satellite images show valleys collapsing at unprecedented rates. These thinkers, separated by continents and centuries, all grappled with the same unsettling realization: nature's permanence is an illusion. Modern geologists frame this impermanence with cold data rock layers that record vanished landscapes like pages in a burned book. But artists and philosophers approach it differently. The painter Georgia O'Keeffe captured the raw transience of New Mexico's valleys in her stark, skeletal landscapes, where bones and eroded cliffs whisper of inevitable decay. Similarly, the Navajo concept of hajoa, often translated as walking in beauty, embraces the cyclical nature of creation and destruction, seeing vanished valleys not as losses, but as necessary transformations in Earth's endless reinvention. Perhaps the most poignant meditation comes from the Andes, where Quechua elders speak of Pachacuti, a world-turning moment when the old order collapses to make way for the new. Their stories describe valleys sinking not as tragedies, but as corrections, a recalibration of balance when humanity forgets its place. This world, you find strange resonance in the notebooks of Leonardo da Vinci, who obsessively sketched landslides and erosion, scribbling notes about how rivers devour mountains in a relentless cycle. 500 years later, his sketches feel less like scientific studies and more like allegories for human hubris. What does it mean to build civilizations atop landscapes that can vanish in an instant? The answer might lie in shifting our metaphors. We imagine valleys as permanent features, bowls to hold our cities, canvases for our agriculture. But in geological terms, they're more like waves, temporary crests in Earth's ever-shifting surface. The writer Rebecca Solnit puts it beautifully: the ground is not the stage for life, it's a participant, rising and falling with its own agency. This perspective transforms vanished valleys from disasters into dialogues, conversations between human ambition and planetary forces that speak in languages of stone and time. As we ponder these impermanent landscapes, their echoes ripple through culture. composers like John Luther Adams craft symphonies from seismic data, translating the groans of unstable valleys into haunting melodies. Architects in landslide-prone regions now design buildings meant to gracefully dissolve, using biodegradable materials that yield rather than resist the Earth's movements. Even our language adapts. The German word vergänglich, meaning transient, has crept into geological papers describing valleys destined to disappear. These responses, artistic, linguistic, philosophical, all circle the same truth. Vanishing valleys mirror our own ephemeral existence. They challenge the illusion of control that underpins modern life, reminding us that the planet operates on a timetable we didn't write and can't rewrite. Yet within that humility lies a strange comfort. However deep our footprints, however tall our monuments, nature will eventually smooth them over with the same indifference it shows to mountains. The valleys that vanish today will be replaced by new ones tomorrow, in a cycle as old as the continents themselves. And perhaps that's the most profound lesson of all, not just about geology, but about learning to build, create, and love in a world that's always slipping through our fingers. This dance between permanence and change has long inspired artists to capture what scientists measure. From cave paintings of lost hunting grounds to digital renderings of future landscapes, creativity becomes our bridge across time's chasm. And as we'll see next, these artistic interpretations do more than document. They transform loss into something luminous, finding beauty in the very ground that gives way beneath us. When landscapes vanish, artists become the keepers of memory, translating loss into strokes of paint, lines of poetry, and haunting melodies that outlast the valleys themselves. Consider the eerie beauty of Albert Bierstadt's 19th century painting The Lost Valley, where a mist-shrouded chasm glows with spectral light. Though inspired by the American West, the work eerily foreshadowed real disappearances like California's Owens Valley, drained dry by aqueducts decades later. Bierstadt's brushstrokes capture both grandeur and grief, freezing a vanishing world in oils before it slipped into myth. Poets, too, have wrestled with these absences. Pablo Neruda's Ode to the Disappeared Earth mourns Chilean valleys drowned by dams, comparing their submerged orchards to drowned libraries of green, each tree a book of lost stories. Literature transforms geological trauma into narrative. In his novel The Buried Giant, Kazuo Ishiguro imagines a post-Arthurian Britain where entire valleys vanish under collective amnesia, a metaphor for how landscapes and memories erode. More chillingly, Annie Proulx's Barkskins traces deforestation's domino effect, where clear-cut valleys collapse like a tablecloth yanked from under a feast, leaving ecological and cultural wreckage. These works don't just document loss, they dissect humanity's fraught relationship with impermanent terrain. Even speculative fiction gets in on the act N. K. Jemison's Broken Earth trilogy features Sinking Land as both plot device and commentary on climate precarity. Musicians echo these themes in unexpected ways. Icelandic composer Hild Jorgardnadottir's Lost in the Valley uses field recordings from landslide sites, weaving creaking rocks and wind into cello melodies that feel like landscapes unraveling. Meanwhile, the Navajo folk trio Burning Dawn sets traditional stories of vanished valleys to percussion mimicking seismic tremors, blending oral history with geologic reality. These creations aren't mere elegies, they're bridges between scientific fact and emotional truth, helping us mourn what instruments can measure but not restore. For those craving art that marries science with soul, start with geologist-artist Maya Lin's Ghost Valleys series topographic sculptures laser cut from recycled steel, their contours based on LiDAR scans of collapsed landscapes. Poet-geographer Barry Lopez's Horizon pairs Arctic permafrost maps with verse, while photographer Diane Tuft's The Unseen Scene exposes ultraviolet images of drying valleys, revealing cracks invisible to the naked eye. These multidisciplinary works prove that understanding and feeling aren't opposites, they're partners in grappling with planetary change. What unites these artistic responses is their refusal to simplify. A valley's disappearance isn't just data or tragedy. It's a mosaic of eroded homes, rewritten ecosystems, and cultural identities unmoored. By giving form to these layered losses, artists do what satellite images cannot. They make absence palpable. And as governments confront the practical realities of vanishing landscapes, these creative voices become crucial reminders of what's at stake, not just real estate, but the stories, memories, and meanings etched into the land itself. Governments walk a tightrope when it comes to vanishing valleys, balancing economic development against ecological preservation, often with lives hanging in the balance. Take Nepal's current land use policies, which still allow unchecked construction on landslide-prone slopes despite the catastrophic losses in 2015. Entire villages rebuild in the same unstable valleys, their concrete homes no match for the next inevitable slide. Yet contrast this with Chile's revolutionary approach after the deadly 2017 Punta Cola collapse. Their new early warning system, a network of tilt meters and groundwater sensors, now gives communities up to 12 hours notice before a valley buckles. The technology isn't foolproof, but it's already credited with saving thousands during the 2021 Los Rios landslide. Success stories like Chile's shine brighter when compared to systemic failures elsewhere. Indonesia's disaster agency still classifies most sinkhole-prone regions as safe for mining, prioritizing nickel extraction over the valleys that literally disappear beneath miners' feet. Meanwhile, Switzerland's Slope Watch program proves there's a better way. By mandating that every alpine valley undergo annual LiDAR stability scans with results publicly accessible, they've turned landowners into active participants in preservation. Farmers receive subsidies to plant deep-rooted vegetation on unstable slopes, while developers face hefty fines for ignoring red flags. It's a model that treats valleys not as disposable real estate, but as living systems requiring stewardship. The starkest policy gaps emerge in how we value Indigenous knowledge. Canada's Yukon Territory recently set a global precedent by incorporating Tlingit elders' oral histories into official landslide risk maps. Their centuries-old stories of the valley that walked aligned perfectly with modern seismic data, revealing unstable zones that geological surveys had missed. Yet in Brazil's Amazon basin, similar wisdom from the Yanomami people about sacred, sinkhole-prone valleys is routinely dismissed even as illegal gold mines trigger collapses that poison entire watersheds. Effective protection requires more than just reaction. It demands reimagining how we govern fragile landscapes. New Zealand's Te Ora Act grants legal personhood to a vanishing valley ecosystem, allowing it to be represented in court by tribal and government guardians. This radical approach has already blocked destructive logging projects that would have accelerated erosion. On the opposite end of the spectrum, Pakistan's glacial lake warning systems, funded by the UN but maintained locally, show how international partnerships can equip vulnerable nations with life-saving tools. The missing piece in most policies, teeth. Italy's post-Valpolar laws mandated slope stabilization, but chronic underfunding left high-risk valleys unprotected for decades. Similarly, California's sinkhole disclosure laws are so riddled with loopholes that homebuyers often discover the danger only when their driveway cracks open. What's needed are binding, cross-border agreements like the Alpine Convention. where 8 European nations jointly monitor and protect unstable valleys, proving that geological hazards don't stop at passport control. Viewers might assume these decisions happen in faraway legislative chambers, but citizen pressure shapes policies more than most realize. When residents of Colorado's Elk Creek Valley noticed increasing landslides from fracking operations, their homemade GPS monitors provided the data that forced stricter drilling regulations. In Japan, grandmothers in Shizuoka Prefecture formed a human chain to block unsafe construction in their collapsing valley, sparking a national movement for better zoning laws. The lesson is clear: protecting valleys starts with people who care enough to speak for landscapes that can't speak for themselves. And as we'll see next, you don't need a geology degree to make a difference, just the willingness to act. Every one of us holds the power to protect Earth's vanishing valleys, not through grand gestures, but through everyday choices that ripple across ecosystems. Start by supporting conservation groups with boots on the ground, like the International Landslide Consortium or the Mountain Legacy Project, which trains local communities to monitor unstable slopes using simple smartphone apps. Even small donations fund crucial tools. $20 might purchase a soil moisture sensor for farmers in the Andes, while $50 could print educational comics warning Himalayan children about landslide warning signs. For hands-on involvement, join citizen science initiatives like NAS, a landslide reporter, where hikers upload photos of cracking trails or leaning trees, data that's helped predict 3 major valley collapses since 2020. Your travel habits matter more than you might think. Before booking that dream trek to Nepal's Annapurna Circuit or Peru's Colca Canyon, research tour operators certified by the Global Sustainable Tourism Council. These companies minimize erosion by sticking to established paths, pack out all waste, and hire local guides who know how to read the land's subtle warnings. Skip the Instagram trend of hidden valley exploration. Those off-trail adventures often trample fragile vegetation holding slopes together. Instead, visit UNESCO global geoparks like Norway's G-Norvegica, where your entry fee funds slope stabilization and educational programs. At home, shrinking your carbon footprint directly reduces pressure on vulnerable landscapes. Meat-heavy diets drive deforestation in the Amazon, accelerating erosion in valleys downstream. Swapping just 1 beef meal a week for plant-based options saves an estimated 800 gallons of water annually. Energy choices matter too. Switching to a renewable provider can cut your household's contribution to glacial melt, which destabilizes alpine valleys worldwide. Even your shopping habits play a role. Fast fashion synthetic fibers shed microplastics that clog soil pores, increasing landslide risks. Opt for natural materials or second-hand gear instead. Young activists are rewriting the playbook on geological preservation. In the Philippines, the Youth for Landslide Awareness movement uses TikTok to teach millions about slope stability through viral dance challenges mimicking warning signs, like the creaking knees move symbolizing shifting bedrock. Meanwhile, Kenya's Valley Guardians program empowers teens with GPS units to map cracks in their communities, blending traditional knowledge with tech. These efforts prove conservation isn't just for scientists, it's a collective responsibility where every voice, especially the next generations, can spark change. The simplest tool might surprise you: storytelling. When you share articles about vanished valleys on social media, use #VanishingValleys to amplify awareness. Better yet, record oral histories with elders who remember landscapes before they disappeared. Their anecdotes often contain ecological clues professionals miss. In Alaska's Yukon Delta, such stories helped identify a thawing permafrost valley months before instruments detected its collapse. While we fight to protect what remains, some valleys defy all explanation. Their disappearances so baffling they've become the Everest of geological mysteries. From the Arctic's humming craters to Bolivia's shape-shifting lowlands, these enigmas remind us that for all our knowledge, Earth still keeps secrets written in disappearing ink. Some valleys vanish with a clear culprit, a landslide, a sinkhole, human interference, but others disappear without leaving behind a single clue that fits neatly into scientific frameworks. These are the Earth's true enigmas, the cases that make geologists pause mid-lecture and historians flip back through ancient texts searching for answers that aren't there. Take Bolivia's Val de los Animas, a high-altitude basin that literally vanished overnight in 1982. Satellite images showed no seismic activity, no water saturation, no mining or deforestation. Just a valley that was there one day and gone the next, replaced by a depression so precise it looked like a cookie cutter had removed a slice of the Andes. Teams rushed to study the site, expecting to find evidence of a hidden cavern collapse. Instead, they discovered something baffling. The walls of the depression were smooth, almost polished, with no rubble or debris at the bottom. It was as if the valley hadn't collapsed but been erased. Then there's Russia's Potomsky crater, a bowl-shaped scar in the Siberian taiga where a forested valley once stood. Locals swear the ground boiled before the trees sank into the earth in the 1940s, leaving behind a conical pit with no clear geological origin. Theories range from a secret uranium explosion to a meteorite impact, but radiation scans show nothing unusual, and the crater's shape doesn't match any known cosmic collision. Even stranger, the pit is still growing, swallowing another 3 to 5 feet of surrounding forest each year, with no detectable pattern or trigger. Scientists have dangled sensors into its depths, drilled cores from its edges, even dropped cameras down its throat, only to conclude that whatever's happening beneath the surface defies every textbook model of erosion or subsidence. The allure of these mysteries isn't just about the how, it's the why. Why do some valleys vanish without leaving behind the telltale scars of landslides or sinkholes? Why do others, like Turkey's Suruk Valley, reappear centuries later as if the earth changed its mind? In 2014, farmers near Antakya reported cracks in their fields, followed by a low, persistent hum. Within weeks, the ground buckled upward, resurrecting a valley that Ottoman records claimed had collapsed in 1693. Geologists called it tectonic reflux, a term they invented on the spot because no existing concept could explain it. The event upended assumptions about how landmasses behave, proving that sometimes the planet operates outside the rules we've written for it. Ongoing research leans into the unknown. In Norway's Hesteland Valley, where an entire lowland flickers with unexplained lights before sections of terrain vanish, scientists have set up a permanent observatory to monitor electromagnetic anomalies. Their data suggests a possible link between plasma phenomena and rapid erosion, but the findings are so controversial that papers keep getting rejected by peer-reviewed journals. Meanwhile, in China's Jingxing County, a team is testing a radical theory that certain valleys might be collapsing due to resonant frequencies, sound waves from distant industrial activity destabilizing already fragile rock. It sounds like science fiction, but their preliminary experiments show that playing specific low-frequency tones can induce miniature landslides in lab settings. For every valley that vanishes without explanation, there are a dozen theories, some grounded in cutting-edge geology, others veering into the speculative. Could quantum tunneling, usually discussed in particle physics, play a role in sudden subsidence? Might there be undiscovered geological processes lurking in Earth's crust, waiting for the right conditions to snap a landscape out of existence? The internet brims with wilder ideas, portals to hollow Earth, alien mining operations, even time warps. While science dismisses these, the persistence of such myths speaks to something deeper: our need to fill voids, literal and metaphorical, with narratives that make sense of the senseless. This is where you come in. Maybe you've hiked a valley that felt unnervingly unstable, or your grandparents told stories of landscapes that disappeared in your homeland. Share them in the comments. Your anecdote could be the missing piece that helps researchers connect the dots. After all, some of history's greatest geological breakthroughs started with local knowledge that defied conventional wisdom. And as we prepare to revisit the key threads of this mystery, remember, the valleys that refuse to explain themselves aren't just gaps on a map. They're reminders that Earth, for all our satellites and sensors, still keeps secrets written in a language we're only beginning to decipher. Earth's vanished valleys are more than just gaps in the landscape. They're portals into the planet's restless soul, where geology, human ambition, and cultural memory collide. From the Himalayas to the Andes, these mysterious disappearances share a common thread: the fragile balance between solid ground and the invisible forces that undermine it. We've seen how water, whether as relentless rain, thawing permafrost, or pumped-out aquifers, can turn bedrock into a liquid nightmare, swallowing valleys whole. We've traced the fingerprints of human interference, from deforestation's deadly consequences to the way mining and urbanization hollow out the earth like termites in wood. Yet these events aren't just scientific case studies, they're chapters in a deeper story about how societies respond to the unimaginable. Indigenous warnings etched in folklore, the grief of displaced communities, and the eerie accuracy of ancient accounts all remind us that vanishing valleys are as much about people as they are about plate tectonics. The cultural echoes of these events linger long after the dust settles. Legends of drowned kingdoms and cursed lowlands aren't mere superstition, they're oral archives of real disasters, passed down with startling precision. The Quechua's tales of mountains drinking valleys mirror modern LiDAR scans showing destabilized slopes. Celtic myths of kingdoms swallowed by waves align with coastal erosion maps. These stories aren't just poetry, they're survival guides encoding generations of hard-won wisdom about where and how to build a life on unstable ground. Even the art inspired by these losses, from Bierstadt's haunting landscapes to Neruda's elegies, captures a universal truth: when the earth disappears beneath us, it takes pieces of our identity with it. What ties these threads together is the undeniable interplay between human choices and planetary forces. The Atabad landslide didn't just happen, it was accelerated by glacial melt linked to climate change. Indonesia's sinking valleys aren't random tragedies, they're the direct result of unchecked groundwater extraction. Yet within these sobering realities glimmer lessons for resilience. Switzerland's slope monitoring networks, Chile's early warning systems, and New Zealand's legal personhood for ecosystems prove we can adapt if we prioritize foresight over short-term gain. The vanished valleys we've lost are irrevocable, but they're also compasses pointing toward a future where we listen to the land's whispers before they become screams. As we stand at the edge of these absences, their message is clear: the ground beneath us was never as permanent as we imagined. Valleys vanish because the earth is alive, shifting, and rewriting itself in a language of rock and water that we're only beginning to decode. But within that uncertainty lies an invitation to build differently, to remember deeply, and to recognize that the most enduring landscapes aren't those that never change, but those whose stories we carry forward, even after the land itself is gone. Earth's vanished valleys haunt us not just because they disappear, but because they force us to confront the fleeting nature of the ground we take for granted. These lost lowlands are more than geological oddities, they're mirrors reflecting our own impermanence, woven from equal parts science, history, and enigma. Consider how the same forces that erased Bolivia's Val de los Animas also shaped the Alps and the Himalayas, reminding us that the planet operates on a timescale where mountains rise and fall like breath. The allure isn't just in solving the mystery of their disappearance, but in sitting with the unanswered questions. What stories did these valleys take with them? What might they teach us about resilience, adaptation, or humility? There's wisdom in the way indigenous cultures speak of these events not as disasters, but as conversations with the earth. The Quechua concept of Pachacuti, a world rebalancing moment, or the Navajo's Hajara, finding harmony in change, offer frameworks far richer than our clinical terms like erosion or subsidence. These traditions don't just describe valleys vanishing, they reveal how to live alongside the instability, weaving ecological respect into daily life. Modern science is catching up, with geologists like Dr. Elena Petrov noting, "The most stable landscapes aren't the ones we control, but the ones we listen to." Preservation isn't about freezing valleys in time, it's about recognizing their dynamism. Switzerland's Slope Watch program and New Zealand's Legal Personhood for Ecosystems prove we can protect without stifling, monitoring shifts without denying them. The challenge isn't just technical, it's philosophical. Do we see ourselves as tenants of the land or as partners in its evolution? The answer might lie in the words of poet W. S. Merwin, "On the last day of the world I would want to plant a tree," a reminder that stewardship isn't about permanence, but about participating in the cycle. As we close this exploration, the invitation isn't to mourn what's lost, but to engage with what remains. Dive into the digital archives, hike with an eye for the land's subtle warnings, or share your own stories of shifting landscapes in the comments. Every vanished valley holds a lesson about the planet's power, the fragility of human memory, or the resilience of life that finds a way even as the ground gives way. If these hidden stories captivated you, imagine what other mysteries await. Hit subscribe and let's keep unearthing Earth's secrets together, one disappearing landscape at a time.